Now dear student, we are going to discuss this question number 10.21. Clear? In this question it is given to you a tank with a square base of area 1 meter square is divided by a vertical partition in the middle. Clear? So now I can say let's suppose I am taking here this is a tank. Clear? Let's suppose I am taking this is a tank. Clear? And in this tank we have a square base. So you can assume this base is having a square and area is also given to you, this is 1 meter square. Fine. Now it is divided by a vertical partition in the middle. So let's suppose I am having here this vertical partition. Clear? This is a vertical partition I am having. Clear? Okay. The bottom of a partition has a small hinged door. So let's suppose this is a small hinged door and this area it is given to you 20 centimeter square. Clear to you? Yes. The tank is filled with water in one compartment. So let's suppose first I am filling water in this compartment. Here we have water. Clear? So I can say here we have water. Clear? And now it is also given the tank is filled with water in one compartment and an acid in the other. Clear? So let's suppose I am saying this side we have acid. Clear? Acid. Fine. Now it is also given both to a height of 4 meter. It means this height, this vertical height is given to you 4 meter. Fine. Compute the force necessary to keep the door closed. Clear? Now let us try to understand this question. Let's suppose I am actually, you can see here we have a container. In this container we have two partition and at the one side we have water, another side we have acid. Clear? And at the bottom we have a hinged door. And let's suppose if we want to keep this hinged door closed, it means we can say net force acting on this hinged door, it should be 0. Clear? So first we can calculate here that force that is exerted by water side, what is force that is exerted by acid side. Clear? So for that one first we calculate pressure. Clear? So let's suppose I am saying this is part 1 and let's suppose part 2. Clear? So first of all I am calculating here pressure due to part number 1. Clear? So I can write like this P1. Clear? P1. Clear? Directly you can say you can take here atmospheric pressure also. Yes or no? Yes or no? We can take here atmospheric pressure. Yes. Or you can also take here gauge pressure. Why? Because atmospheric pressure will come at both sides. Clear? Definitely it will be cancelled out. So directly I am saying here I am writing this is gauge pressure, this is rho gh. Clear? Now if I am talking about water, so this is density of a water and height of a water column. Clear? So density of water is given, this is 1000, we know very well. Value of G I am taking, this is 10. And what about the height of water column? Height of water column is given to you 4 meter. Clear? So from here we can say, we can write like this, this is 4 multiply 10 to the power 4. Clear? And I can say this is Newton per meter square. Same we can calculate value of P2, pressure that is exerted by acid side. Clear? You can say here we are having this is P1 and let's suppose we are saying this is P2. Clear? So we can say this is density of acid G and height of acid column. Clear? Now it is given relative density we have 1.7. So we can say this is 1.7 into 1000 and it is multiplied with G and height of water or acid both are given, that is same. So I can say this is multiplied with 4. Clear? So now we can write like this, this is equal to 4 into 10 to the power 4 into 1.7 Newton per meter square. Now if you observe, definitely you can say P2 is greater than P1. Clear? It means we can say pressure that is exerted by acid side, this is more compared to pressure that is exerted by water side. Clear? So now we can say our objective here is to calculate net force. So we can write like this, net force, this is given by P2 minus P1 and multiplied with this area. Clear? So now we can say P2 minus P1. Clear? So P2 we can say we have 4 into 10 to the power 4 into 1.7 and this one. So you can take here 4 into 10 to the power 4 common. Clear? I can write like this 1.7 minus 1 and multiplied with area. Now we will take here this area of a hinged door. clear, and area of a hinge door is given to you 20 centimeter square. So I can write like this, this is 20 into 10 to the power minus 4, clear to everyone. So now we can say this is 4 into 10 to the power 4 multiply 0.7, and we can say 20 into 10 to the power minus 4, clear. So now I can say here, if you calculate, I am just rubbing here, clear. Yes. So now from here we can say net force, F net. This F net that is given by 4 into 10 to the power 4 into 0.7 into 20. So if you multiply, I can say this is 80 into 10 to the power 4 into 7 by 10 multiply, clear. We can say this is, you write here, this is 4 multiply 20, fine, 10 to the power 4, 7 by 10, clear, and we can say this is 10 to the power minus 4, this one and this one cancelled out, clear. So from here you can say, we can write like this, divide by 10, and this is equal to 56 Newton, clear. So now we can say net force that is exerted on this hinged wall, this is equal to 56 Newton, clear. And definitely this force is actually more from this acid side. Definitely we can say at this time this hinge door will not be closed, because force exerted will be more by the acid side. Now what we can do, actually if we apply same force from water side, at that time we can say this hinge door will be closed, clear. So now we can say force exerted by water side to keep hinged door closed, clear. So I can say this is equal to what, this is equal to 56 Newton, clear to everyone. So this is all about this question.